Number 10 says, which graph represents the function f of x equals x minus 3 squared plus 3? Well, if you notice, this is a square. So that means that I'm talking about a quadratic. Which a quadratic, the parent function should look like this. Okay? So basically, if I have a negative, that means this is going to be reflected. It's going to be turned upside down. So off the bat, I can cancel this guy and this guy. Okay? And I noticed that this is plus 3. So in other words, this was my parent function. When I got the negative, it got reflected. The plus 3 means it goes up 3. And the minus 3, if you remember, this is a horizontal movement. And this is counterintuitive, so it's going to move to this direction. So that's what's going to be my graph. So my letter is letter F. Alright? Now that's how you do it graphically. Now, but remember one thing. You have your calculator. Right? You can always use a calculator. So let's press clear. Let's press Y. Let's go ahead and clear everything that we have there. Whoops. Clear. Clear. And number 4. Where are you? Clear. Alright. Let's go there and enter what we see. X minus 3 square plus 3. And guess what? Let's press graph. And if you look at that, what does it look like? Letter F. Okay? Alright. Let's do number 11 now. The graph of the quadratic function f is shown on the grid below. Okay. If the graph f is translated 5 units to the right, so let's go ahead and move 1, 2, 3, 4, 5. Okay, and 4 units down, 1, 2, 3, 4. So basically my graph will look like this, right? Okay. To create a new graph, which function best represents the new graph? Okay, so let's take a piece of paper here. Okay, remember that this graph here looks like a quadratic, so my equation is y equals x squared. Okay, now this is the parent, but because it looks upside down, I know that I'm going to have a negative in front. So basically, that's what happened. It got reflected. Okay. Now here's my original one. I went from here to there. So basically, I'm moving 1, 2, 3. So 3 to the right means that over here I'm going to have minus 3 squared. And then I went 1 down, which means negative 1. So if I look at my multiple choices, my answer is D. Okay, let's go ahead and do number 12. Number 12 says, what are the zeros of the polynomial p of x equals x cubed minus 2x squared minus 23x plus 16? Okay, I want you to remember one thing. Every time you see the word zeros, or maybe x-intercepts, like on problem 14, or solutions, okay, or even the word roots, they mean all the same thing. It means like if you have a graph, where does the graph hit the x-axis? And that's what the zeros are. That's what the x-intercept are, or the roots, or the solutions. Basically, you're looking for something that equals 0. So basically, the problem is asking which one are the numbers that's going to make this equal 0. Okay, the best way to check this is you can we can use the calculator. Okay, use the strategy that I taught you. So let's go ahead and turn on the calculator. Press second memory 712. Right, we cleared the calculator. Second table setup, and let's go to ask. And remember, if you did this at the beginning of the test, then the calculator is set up for the rest of the test. You know, you don't have to be doing this all the time. I'm just doing it to remind you how to do it. Okay, and remember that press enter and then press second table, and you'll be able, your table should look like this. Okay, when I enter this equation under y, so we're going to press x raised to the third power minus 2x. Okay, gotta be careful with my calculator here. It's a new addition, so let me clear that. Now, so this would be 3. Then I need to move out down. Negative 2x squared. Move down. Negative 23x plus 60. And just double checking I did it correctly. Alright, it looks good. So let's go ahead and press second graph or second table. And now when I enter this number here, and I'm looking for something that gives me 0. If I enter negative 15, it does not give me 0. So guess what? I know multiple choice A must not be the answer. Alright, let's try this guy right here, or either one. So let's try this one. 2 does not give me a 0, so I know this is not the answer. And I know this guy has a 2, so it's not the answer. It must be B, so let's just double check. Let's enter negative 5, and I get a 0. 3, I get a 0. 4, get a 0. So this is confirmation, that's my 0. Okay? And let's look at problem number 14. What are the x-intercepts of the graph of the function y equals x squared plus 2x minus 15? Man, the same type of problem. All you have to do is press y, clear, enter the new equation. X squared plus 2x minus 15. Press enter. Second graph. And let's go ahead and delete that. And let's enter the new numbers, which would be 3. So that's 3. Okay, 3 gives me a 0. Let's try the negative 5. Negative 5 gives me a 0. So I know off the bat that that's my answer. Just for the sake of checking, let's try number 2. Should not give me a 0. That's right. And let's try number 5 there. See, it doesn't give me a 5. So you're looking for something that gives you a 0. Let's try number 15. What are the solutions of the equation 1/4 x plus x minus 8 equals 0? Again, you want equals 0, so you press y, clear, 1 divided by 4x squared plus x minus 8, and press enter. Now we're going to go to the table and we're going to start entering the numbers. So let's try number 8. Does not give me a 0, so 8 is not the answer. So off the bat you can cancel these two. Let's try negative 8. Aha, it gave me a 0. So that now the question is it 4 or 1/4? Let's try 4. Aha, it's letter B. Just for the sake of checking, let's try 1 divided by 4. Okay, so you know it's not the answer. Okay. Alright, let's do number 13. I skipped 13 for a reason because you gotta watch out. Because let's read the question. Which of the following quadratic functions does not have zeros at negative 15, 6? So basically here the keyword is not have zeros. So now I don't want zeros. So let's press Y. Let's clear it. Let's go ahead and enter those equations. 1 divided by 3 x squared plus 3x minus 30, right? And let's try negative x squared minus 9x plus 90. And next one is negative 2 divided by 3x squared minus 6x plus 60. And the next one is negative x squared minus 9x minus 90. Alright, now we enter all those. Let's just check real quick if everything is correct. Okay, looks pretty good. Alright, so let's go to our table. and we're looking for something that does not give me 0 for the numbers negative 15 and 6, because remember these numbers are from the previous problem. Let me move over here so I can see it better. There's better. So let's go ahead and clear it and delete that. Let's enter the number negative 15 and 6. If you notice, number 1 gives me a 0, but I don't want 0. So A is not, B is not. Let's keep going. C is not. The answer is letter D. Alright, very good. So please remember that you can use your calculator to do these problems on the test. Okay, let's go ahead and go to problem number 16, and we're still using your calculator. Okay, alright, so let's take a look here. Number 16. Okay, number 16, it has a table, so but also has all these equations. If you see a list of equations like this, it's a good indicator that you can use your calculators. So let's go ahead and press Y, and let's delete everything or clear everything. Alright, let's enter our new equation. So x squared minus 3x minus 4, x squared plus 5x plus 4, negative x squared plus 3x plus 2, and negative x squared plus 2x plus 3. Alright, verify that you didn't make any mistakes entering. Alright, basically we're going to go to our table. I'm going to delete what we had from the previous problem, and here are my values of x. So I'm going to enter that. Negative 1, 0, 1, a 1, and a 2. And basically I'm looking for these numbers that I see on the table. I don't see it for 1. I don't see it for 2. I don't see it for 3. And I see it for 4. I notice that I entered the 1 twice. That's okay. Alright, so we know that is answer letter D. Okay, let's go ahead and enter this one right here, because I believe this one you can use a calculator too. Whenever you notice something like this or like this, you should try it using the calculator. Okay, so let's go ahead and do number 19. So let's clear it. Alright, so we have negative 16.5x plus 125, negative 0.06 x plus 7.6, 0.06 x plus 10, 7.6 minus 0.06. Alright, double check it to enter correctly. Alright, press second that. I'm going to delete everything. Now, see, if you read the problem, the following list shows the number of people in millions in the United States whose only means of getting to work was walking. If x equals 0 for the year 40, so that means this is year 40, so this is 0, this would be 10, 20, 30, 40, and 50. So that's the numbers we're going to use for x. So 0, 10, 20, 30, 40, and 50. And we're looking for these numbers here, and we can obviously see that if you don't pay close enough attention, you'd see that this one it starts off good, but then after a while doesn't work so good. It's off by 0.1. So let's check the other ones. Well, I guess they're pretty good. This one is pretty good, so letter B is the right answer. Okay. Alright. Let's do problem number 17. How is the graph of y equals x plus 2 squared minus 1 obtained from the graph of y equals x squared? Oh, this is pretty cool. Basically, here's your parent function, right? Basically, is asking what's going to happen if I do this here. Well, basically, the minus 1 means it goes down 1, and the plus 2 means it's counterintuitive, so I go left 2. So down 1, left 2. So let's see. Shift the graph up 2 units? No way. I went down 1 unit. Shift the graph left? Yes, I did left 2 and down 1. That's my answer. Let's do problem number 18, which says, which quadratic function has a maximum but no real zeros? Notice I have a list of functions over here, so I'm going to go ahead and graph them. And press my Y button and enter the equations. Minus 1. We have 5x squared minus 2x plus 3 negative 4x squared plus 3x minus 2 and negative 3x squared plus 8x minus 5. Alright, let's double check if I enter everything correctly. Looks good. So now what I'm going to do is I'm going to press graph and look at the graph. Move the calculator here more to the center. You can get a better picture. Okay. Press graph. And that's going to be my first multiple choice. That will be my second. Here comes my third and my fourth. Okay, as we can see, the first and second multiple choice were graphs that were like a smiley face. Okay? In other words, you have like a minimum here, and we're looking for a maximum. So I know that my first two choices are not the answer. So I'm going to go ahead and cancel them. Okay? Also, another way you can do is, if you notice here is positive numbers, that means your function is going to be like a smiley face, because it's like having money in the bank. You're always happy when you have money in the bank. And these two over here are negative, so like you don't have a smiley face when you don't have money in the bank, so it's looking upside down. So we know that the answer is going to be either C or D. So let's go back to our graph here, and let's go ahead and delete the first two because we don't care. So let's press clear and press clear, and let's go back to our graph now, and I'll be able to only see the first two. Okay, and as you can see, the first two are like that. What I'm going to do, I'm going to show you a closer picture of the graph. So let's press zoom, or let's press window, and let's make it so the y value is, let's say, 1, and the y5, let's say, was let's say 5. Should give us a closer picture of the graph. Okay, that's my first graph. This is my second graph. Let's go also change the window in this way. So let's say I change it to, let's say, -3 and 3, just to give you a better picture of the graph. Alright, so that's my graph, and that's my graph. Well, if you noticed, the question is asking which has a maximum, both have maximum, and which one has no real solution. Well, this guy here has two solutions, so you know that the fourth answer has real answers, meaning numbers that touch the x-axis. The other one does not have real answers because it does not touch the x-axis. Okay, so the answer is letter C. Alright, another way to do this problem over here is, once we decided that these two are the ones that have maximums, I can remember I can use my quadratic formula, which, if you remember, is x equals negative b, positive negative b squared minus 4ac divided by 2a. Well, if we just use the radical right here, okay, and basically the radical here is called the discriminant, and this radical here is going to tell us if we're going to have real answers or real zeros or not. Basically what we have to do is just plug it in the numbers. So let's plug it in 3. It would be 3 squared minus 4 times a, which happens to be negative 4, times c, which is negative 2. Alright, if we plug that in, this would be 9. Negative times a negative times a negative is a negative. 4 times 4 is 16, times 2 is 32. Alright, so this will be negative 23. Alright, now you notice you have a negative inside the radical. That means what? The negative is going to come out as an I, which is an imaginary number. In other words, not a real number, not a real zero. So if you want to check the letter D, which is supposed to have a real answer, so let's see. What's going to be the discriminant of that function? We're going to put the 8, so it'll be 8 squared minus 4 times a, which is negative 3. A is the first number, times the c, which is the last number. Alright, so this would be 64, and negative times a negative times a negative is a negative. 4 times 3 is 12, times 5 is 60. Guess what? Guess square root of 4, which is 2, which happens to be a real number. So I know that this function here is going to have 2 real answers, 2 real zeros, when this one didn't. So there is 2 ways to approach this problem. Okay, you can use a calculator, obviously. 2, you can use the fact that these are positives, so that means you're going to have minimums, and these are negatives. That narrows the multiple choices down to 2 multiple choices, and then you can use the discriminant to decide which one's going to give a real answer, which one will not. All right, sounds great. All right, now let's focus our attention to number 12. So let's move a little bit closer over here. Okay. Let me get some white paper here for us. Alright. Here we are. Number 20. If a function f of x is changed into f of negative x, what transformation will take place? A lot of people think that this will be a reflection over the x-axis, right? Something like this. But that only happens if the negative is outside the function or in front of the function. What we're talking about here is a change in the sign inside the parentheses, inside the x. What that means is a reflection over the y-axis. Okay, so basically what would be something like this. Okay, so it's reflecting over the y-axis. Here will be reflecting over the x-axis. So if you see a change of negative in front of the x inside the parentheses, you know that's going to be a reflection over the x-axis. If it's in front, then it's over the x-axis. Okay, so according to our problem here, our answer is letter G. Okay, we are on problem 21. The outside edge of a rectangular pool deck measures 60 feet by 40 feet as shown in the diagram. The distance from the edge of the pool to the outside of the deck measures x feet. Write an equation to represent the area of the pool deck in square feet. So basically here you have a pool and you have the outside edge of a rectangular pool deck. So the place where you walk around the pool. Okay, and it measures 60 feet. So this is 60 feet. This is 40 feet as shown in the diagram. The distance from the edge of the pool to the outside of the deck measures x feet. Okay. Write an equation to represent the area of the pool deck in square feet. Well, the area of the pool would be a rectangle, so it would be length times width, right? And we want to find out the area of this. So basically what I'll do is I'll come up with a game plan, which would be the big area minus the area of the pool. And as I recall, area of a rectangle is length times width, length times width. So let's start out with the length of the big rectangle, which would be length would be 60 and the width would be 40. And the length of the pool would be, well, this would be 60 feet minus x, so minus 2x. So 60 minus 2x. And the width would be 40 minus x, so minus 2x. Alright. So now that we have that, we can use FOIL, which we learned in class. So here first we're going to multiply, so it would be 2400. I'll put the minus here and I'll put a big bracket because I'm going to FOIL first and then I'm going to distribute the negative. So we're going to have what? Remember FOIL? First. So first with first would be 2400. And then outside with outside, it gives you negative 120x. Then the inside, negative 2x times 80 is negative 2x times 40 is negative 80x. So this would be negative 200x. And negative 2x times negative 2x is positive 4x squared. Very good. Now I'm going to use the distribution. So this would be 2400. Okay, let me move this up a little bit. There we go. Sorry, it's kind of hard to see there. Alright, here we go. 2400 minus 2400 plus 200x minus 4x squared. Alright, we notice that these cancel. So that means the area of the deck will be 200x minus 4x squared. And hopefully I can see that. Yes, I do. Letter G. Alright. Isn't that cool? Excellent. Alright.